Hey everyone, welcome back. Today we are going to be doing another problem in our LeetCode 75 study plan series. Today we are moving on to a new section. This is called Prefix Sum, and we have two easy problems. So the first problem is find the highest altitude. All right, and the instructions are there is a biker going on a road trip. The road trip consists of n plus 1 points at different altitudes. The biker starts his trip on point 0 with an altitude equal to 0. You are given an integer array gain of length n, where gain at index I is a net gain in altitude between points I and I plus 1 for all 0 is less than or equal to I and I is less than n. Return the highest altitude of the point. All right, so I feel like those instructions are a little more complicated, worded a little bit more complicated than it needs to be. You're basically just trying to find the highest gain from point to point. And the reason why it's in the prefix sum category is that we're using basically the cumulative sum of the different altitude points, right? And we're starting at 0. Basically, it's we can look at the example right here, right? We're given an integer array, and some of these can be negative. And then we're going to output 1 because the highest length increase is 1, right? So we start at 0, then we go to -5, and so it goes down to -5 because that's the first one. But then we have a 1 right here at our second index, and then since if you add 1 to -5, we get -4, and that's why we input that there in our third index. So hopefully you guys understand what the problem statement is, and we can go ahead and work on the code implementation for it. It's pretty simple. If you use the right technique, you can get this done with just a simple for loop and a couple of integers. First, what we need to do is we need to initialize a max integer because we're going to need something to compare all the altitudes, right, as we're iterating through a for loop. What we want to do is just do int max, and we're going to set that to 0 because the reason why we're setting it to 0 is since 0 is the first value that we're basically putting at the beginning of an array. So we're always going to compare it to 0 first. And then we want to go through just our standard for loop. We can just use I is less than gain.length, and then I plus plus. Okay, so what we're going to do here is we're going to use a ternary statement. And the reason that we need to use the ternary statement is because we need to identify whether or not the index is at 0. Because if it's at 0, we can't subtract from the previous number because it's the beginning of the array. What we're going to do is we're going to set gain at index I equal to, and then this is where we put the ternary statement. So if I is equal to 0, then we assign it to just gain at I, right? And then if it's not equal to 0, then it's gain at I plus gain at I minus 1. And just to help you guys visualize that a little bit better. So look at example 1. If we have 0 and then we're going to -5, we can't subtract. There's no point in adding 0 because 0 is always going to be the first index. So there's no point in adding 0 to -5. It's going to be -5 anyways. That's why we do gain of -I here, and we also don't want to run out of an out of bounds exception because there's no such thing as a -1 index in an array. So now that we have that sorted out, what we have to do now is compare the number and set the max for each iteration of the loop. So we just do max is equal to, and then we're going to use our built-in math.max method from the math library that comes with Java. And then we're just going to feed in max and then gain at I. And then keep in mind that gain at I is set to a new value, the updated value that accounts for the difference in altitude for each iteration in the input array. So we're using either max or gain, and we're finding the max of those two, and then we're just going to return that value. So return max, and let's go ahead and run this. Okay, cool. We passed the first couple of test cases. Let's go ahead and submit this. All right, there you have it. We have an accepted solution. Beats 100% runtime of 0 milliseconds according to there. Although in theoretical terms, our time complexity is big O of n because we're basically iterating through the input array once. So as you have known, if you've seen my previous videos, that's just going to come out to a time complexity of big O of n. And then for our space complexity, it's just constant. It's big O of 1 because we're not using any data structures or variables that scale with the size of the input. So that keeps it pretty simple, pretty straightforward. All right, so that was our first problem of the prefix sum category. There's only one more to go. It's another easy problem. This has probably been one of the easiest, if not the easiest problem in our series so far. So I hope you guys enjoyed it. And if you found that it was helpful, please go ahead and leave a like and subscribe for more related content. As always, please leave any suggestions that you have in the comment section, and I'll look forward to seeing you guys in the next video. All right, bye now.